Okay, fantastic. My name is Don Fitz, and I've been hosting the flood discussion groups for a bit over a year. Tonight, we're going to have somebody who really knows what he's talking about. Kirkland Preston is with the Department of Public Works, of the Stormwater Department in the city of Springfield. He has a BS in Biological and Agricultural Engineering from Kansas State University, is a registered professional engineer in Minnesota, Wisconsin, and Missouri, and he's a certified floodplain manager. Okay, Kirkland, I think everybody should be able to see the slides that Kirkland had. Let me go ahead and turn it over to you.
Okay, yeah, sounds good. Thanks for having me. So I'm Kirkland with the city. Thanks for the introduction. And so this is just a PowerPoint presentation on the naturalization of Fassnight Creek. It's a capital improvement project that the city of Springfield recently completed a couple years ago. And so I'm the project manager for the city of Springfield. HDR was our design consultant that the city hired to do the modeling and the actual design of the project. And so I'll just do an overview of what I'll cover here. There were some master plan considerations. So the Art Museum went through a master planning effort, and when we did the stormwater improvement, had to conform with some of the design elements that were in the master plan already. And so there were some constraints on the design from out the gate from trying to conform with the master plan. And we'll just cover some stream restoration elements that HDR came up with to design this naturalized channel. And then I'll do a little bit of a construction review. And then at the end, if there's any questions, I'll do my best to try to answer questions. And so just to kind of get people oriented, this is an urban watershed. It's right in the heart of Springfield. It's a big watershed. It's over 900 acres. And so when I'm saying watershed, I'm meaning, anything that falls in that area in red will eventually make its way to the Art Museum. And so what's shown in red there is kind of the outline of the watershed. And if rain falls in that area, it eventually makes its way down to the end of the watershed, which is right at the Art Museum. And so sometimes it even rains way over on the east side of town. It won't be actively raining at the Art Museum, and we'll have an event where the channel's flowing. And that's just an example of how the watershed works when it's such a large watershed. And this project is it's a floodplain improvement project. So the city was notified by FEMA that they were going to issue a preliminary revision on the floodplain mapping. And that mapping revision brought the Springfield Art Museum and several residential properties that weren't in the floodplain into the regulatory floodplain. And so that was the catalyst for the city saying, okay, we need to do an improvement project to bring the Art Museum out of the floodplain, bring these residential structures out of the floodplain. And so we use this modeling and actual flooding events to start to make a design decision. And so this area was an area of known flooding risk even before it was part of this preliminary FEMA floodplain mapping. There was often street inundation due to rain events, and these are just some examples of the flooding. Even due to relatively small rain events, the water didn't have enough area for conveyance, and it would flood into Brookside. And the picture on the right there is a Kings Avenue Bridge. It's actually a box culvert. It was really a restriction, a bottleneck to the channel, and you kind of see in that image upstream of the channel, the elevation of the water compared to downstream. It really illustrates that bottleneck effect that was having. And so as we move forward with the design, we considered what we were seeing and then also the FEMA mapping in making design decisions. And so the existing channel as is before the project was this narrow concrete channel. I think it was built around the 50s. And then the picture there on the right is an image inside that Kings Avenue bottleneck. So that's inside that box culvert. You can see how restrictive that box culvert was to the flow of water. There was a baffle inside of there. And so early on in the design, we knew we had to address that bottleneck. then also early on in the design, we knew we had to conform with some of the constraints and the pre-existing design elements in the Art Museum's master plan. And so this master plan was done by BNIM. It's another consulting firm. And we went ahead and we consulted with BNIM and took this, what we could, forward into our design. You know, some changes had to be made, but we wanted to adhere to the master plan as much as possible. Here's just another rendering of the master plan, and the Art Museum had all these plans, and they're still ongoing to make modifications to the building and the Art Museum grounds. And so this was just really the first step, was to address the flooding for the Art Museum. Even there were concerns that the Art Museum would not be able to get traveling art exhibits due to the liability of the flooding. And so the first thing they wanted to do was address the flooding. And so that's what we did. This is just another image of the Art Museum master plan further upstream, showing some of the bridges and just how little area there was to work with. What's shown there in that paving area, that's Brookside Drive. And then the channel was just immediately south of the Art Museum there. And so what we did to try to get some additional area for the water to flow is we actually modified the Brookside Drive alignment. So Brookside Drive is just south of the Art Museum, and we narrowed the drive lanes as much as we could and pushed that alignment south. And so what's shown in gray is the proposed new alignment of Brookside. So we're actually taking that road and moving it south. And then what's shown in this kind of light yellow orange area is the new additional area we've gained by moving the road south. And then we're also taking out on the far left side is a bridge that used to access the Art Museum parking, and just another obstruction to the flow. And so here's the bridges that were modified or removed as part of the project. So on the far left is that Kings Avenue box culvert, which was very restrictive, and we knew we had to remove that to remove the bottleneck and allow better conveyance. And then there's a couple additional bridges that were just sort of modified and rebuilt, reconstructed as pedestrian bridges, which had a little bit better hydraulic capabilities than the existing bridges. And so doing all that effort and going through the design, HDR was able to model the existing conditions and then model also the post-project conditions. And so what's shown here is in red is the existing conditions, and then in blue is the post-project flood inundation extent. And so what's gained is the difference between the red and the blue as far as flooding. And so it is still an area of risk. It is still an area that will flood, but by doing the project, we were able to mitigate that flooding and mitigate that risk. And this is just some example of the modeling HDR does. This is primarily, it's HEC-RAS, so that's an Army Corps of Engineers modeling platform. It's kind of the industry standard for doing these hydraulic models. And they're able to get a really good understanding of the flow of the water even before any construction or design takes place. So, and HDR went through a lot of considerations for the design for naturalizing a channel in an urban area. There are some challenges. It's typically urban environments have a really flashy runoff. So rain, when it falls, rather than having a chance to absorb and slow down, it immediately will turn to runoff. And that's what we mean by flashy. One of the other challenges of naturalizing a channel in an urban environment is typically creeks and rivers have a sediment load or a bed load that they're continually depositing. But upstream of this natural channel, it's just box culverts. There's a little bit of sediment, but not too much. So they had to consider how to make a stable naturalized channel, considering that there wouldn't be sediment contributions from the upstream channel. And then they didn't know what was underneath the existing concrete, and so they wanted to just, assume that it could just be a mud substrate. It might not be a very good underneath, and we may have to replace a lot of that in order to naturalize the channel. So that was an assumption that was made. And then due to the fact it is a FEMA regulatory floodplain, we were really shooting for the 100-year event to try to minimize that, because that's the regulatory event. And so they incorporated all these different elements in order to naturalize the channel and mimic a natural stream. And so they used void-filled riprap, which I'll cover a little bit later. And then there's some grade control, which are riprap riffles to mimic riffles of a creek. And then there's some stilling pools and native plants with TRM, which is turf reinforcement mat, which I'll also just cover later in the construction section. And so all this goes into the design. And so what's shown on the right is just a post-project when things were still stabilizing and the plants were just starting to grow. And so we covered all this, but we really had to remove Kings Avenue Bridge, and then we reinforced the vegetation with that turf reinforcement mat. And several of the pedestrian bridges were redone so that they're hydraulically able to perform better. And here's an image of the upstream end of the art museum post-project. It's about the same time when the vegetation is still trying to take hold. There were several considerations during construction. These images will be during construction, where it will look a bit of a mess, and that's just part of construction. It's hard to make an omelet without breaking a few eggs, and so these will be a little bit messy. But there are several considerations during construction. We heard from the contractors in Southwest Missouri that they were not comfortable with this void-filled riprap material. Nobody had installed it before, and so we, the city, ended up modifying the specification on how that was installed in order to try to work with the local contracting community the best we could. Initially, it was specified as a composite mix, so the contractor would mix all this material and then install it in the creek as a composite mix. And we heard from the contracting community they were not comfortable doing that, and they were unsure if they wanted to perform in that manner. And so we just revised the spec to almost a lasagna method, where the layers of aggregate were installed, still the same ratios of material, just installed in situ in the channel as the contractor worked their way down the channel. And so the top image shows a composite installation, and the bottom image is from Fassnight Creek, where we did more of a lasagna type of installation, just to show we got a very similar end result, even though we modified the spec to just work with the contractors. It's just an example of what goes into the void-filled riprap. It's really just aggregate materials, river rock, riprap, and all that's mixed together so that the voids of the riprap, the bigger material, get filled with this smaller material, and it forms a dense compacted mass. And that ends up being a pretty stable stream bed to mimic a natural channel. And so here on the left is an example of Fassnight Creek, where this is the reconstructed, this is void-filled riprap on the left. And then on the right is just further downstream an example of what we're trying to mimic. So this is a natural portion of Fassnight Creek. And so we're just trying to mimic what the creek naturally would be. And here in the Ozarks, the creek bottoms are rocky aggregate bottoms. And so we were able to mimic that with this void-filled riprap material. Another benefit of the project is we were able to incorporate a lot of native plantings. And this is just a small list of the native plantings, and I think they're very attractive, and I think they add to the project. You know, at first there is a little bit of public uncertainty about the natives. They have a tendency to be a little more wild looking and unmanicured, but I do think they have their own beauty. And so there's service berry up in the top left corner. That's a flowering berry that provides food for birds and pollinator species. And then chokeberry has some fall interest. There's other flowering plants and grasses and trees that are also attractive and bring spring and fall interest. And so HDR, our engineer, had a landscape architect on the team, and they were able to do this native planting palette, and I think still create a beautiful end result. And so just continuing on with some of the construction, this just highlights the use of TRM, turf reinforcement mat. It's almost, it's kind of like a burlap sack type of a material. It's actually made out of plastic typically, and it's installed on slopes, and then it's seeded and soil is applied. And what that does is it provides an area for the roots of the plants to kind of incorporate with that matting and form a stabilized slope, which is critical on a channel like this when you're going to have water flowing through it. And so it ended up being a really good product for a natural channel. And here's just an illustration, a detail from the plans showing this turf reinforcement mat installation. And HDR did a technique that I hadn't seen before, and I would do it again. It's a highly successful technique. They installed a layer. They specified in the plans to install a layer of TRM, which is the heavier duty plastic matting, and then a layer of topsoil, and then also on top of the topsoil, a layer of erosion control mat, which gets planted. And the erosion control mat eventually biodegrades, over the course of 2 to 3 years, but it really protected the seed bed. And so here's an example of that TRM, that turf reinforcement mat. That's the green kind of woven material that you see on the left. And then on the right is an example. After the seeds and the plants take hold and the roots incorporate, you would not know that that turf reinforcement mat is there. And what you have is a stabilized vegetated channel. And even during construction, we started to see wildlife come in, which was a goal of the project. And the native plantings was to provide food and habitat for wildlife. And it's been a success. It's a relatively densely populated residential area, but there are several bird species, turtles. I've seen a red fox that have come into the project area since we've constructed it. There were a lot of challenges during construction. I'll just kind of cover these real briefly, but it's a challenge for a contractor to work in a channel. Here's just an example. There's all kinds of infrastructure in this channel. There's box culverts, there's sanitary sewer, there's water flowing through the channel. And they're working right in all this. And there's several structural considerations this particular project had. One of them is being so close to the art museum. The piles for the bridge, which are usually, they're driven in typically. These were actually pre-drilled into the bedrock to minimize the vibration experience at the art museum due to sensitive art they have, and just being so close to the building, just liabilities with vibrations. So contractor had to do a lot to not only minimize the vibrations and work in an actively flowing channel. It was a challenging project for the contractor. They did a good job. And throughout, they have to manage the water. Because you can't turn off Mother Nature, and so you're trying to work in a creek, and you'll get rain over the course of construction. And so there's just some examples of how the contractor was able to manage the water. They used temporary dams made out of sandbags and just a pump around through a sediment filter to minimize sediment. And then they also, in the top left-hand corner, used these sacrificial concrete walls that they were able to keep, to a large extent, the channel flow in the existing concrete channel for as long as possible to just keep it out of the construction zone. And so here we go. Here's before is a narrow concrete channel with a large berm, and it really pushed the water onto Brookside, which you see there on the left-hand side of that image. And just to show the amount of cross-sectional area that was gained by doing the project and the amount of area that we were able to allocate to the flow of water. Here's that same area after the project, and it's just been widened. And it really gives the water a lot more, like I said, cross-sectional area for conveyance. That's the goal of the project, is to just allocate some more area for the floodplain, allocate some more area for flow. The city of Springfield was fortunate to partner with a lot of grant agencies who had investment goals that matched very well with the goals of the project. We worked with the Department of Conservation to get a grant for native plantings. We worked with EPA Section 319. There was a grant administered by a local agency called James River Basin Partnership. And that grant's goal was to remove impervious surfaces and install pervious naturalized channel. So it was just a really good fit for the project. We also got a Missouri Department of Natural Resources stormwater grant for naturalized stream restoration. And then the balance of the funds was local tax money, quarter-cent capital improvement sales tax. In total, the project cost about $2.3 million to construct. And here's just an after showing the art museum rendering that HDR had during design, and then the actual after. This is their new signature entry for the art museum. And here's just some after post-project images of after the vegetation has started to take hold and the native plantings are starting to thrive. And here's that Kings Avenue box culvert. It was just removed. It ended up being through the modeling. It was determined the best, most cost-efficient way was to just remove that intersection, remove that box culvert, and eliminate the bottleneck. It was a very there wasn't a lot of traffic on the road, and so it was able to be closed without any impacts to emergency vehicles or traveling public. It's just a local road. And then right after construction, we got a few rain events, and here's just an example of it's actually a pretty it's a pretty minor rain event, really, but it shows just how much water gets in that channel. And this was at a sensitive time for the channel. You know, the grass seed had started to germinate in some areas, and other areas it hadn't. And it's just an example of how that turf reinforcement mat and erosion control blanket is able to maintain a stable bank, even when the seeding hasn't yet germinated. And so it was a pretty good test on the project early on. And that was about a 25-year flood event, or a 1 in 25 chance in any given year. And so based on the modeling, this red dashed line is the approximate elevation at the bottom of these piers. And so that just gave some confidence that the HEC-RAS modeling that HDR did correlated pretty well with the rain event that we got. And we haven't gotten a significant rain event since the project, but at least it gives some confidence that the modeling is it correlates with reality. And so just to summarize here, yeah, we had to adhere to the master plan, and we bid this project a total of 3 times. We revised the specifications quite a bit, and it was right during COVID. A lot of challenges there, supply delays, but you know, thankfully we were able to get it constructed. And it's just a great example that a nature-based bioengineered solution can be a great solution. It's a piece of infrastructure, but it's also an amenity for the art museum and the community. And that's all I have. I'd be happy to try to answer any questions if there are any.
Can you?
Yeah, Claudia, go ahead.
Can you go over the 3 levels on the sloping bank again? The TRM, and then what were the other 2?
Okay, yeah. I can try to pull up that slide again, or I can just, it's kind of an Oreo cookie. So the TRM is the bottom of the cookie, and that's that plastic woven mat. And then there's a few inches of topsoil, and that gets planted with seed. And then on top of the topsoil, or the top cookie, would be the erosion control blanket. And in this case, it was a biodegradable woven coconut mat material. And so that erosion control blanket, that coconut mat material, protected the seed bed even when we got that rain event during construction.
Okay,
Um,
okay.
Would the first level be somewhat like the green crap that when you put sod down on your front lawn, it comes on a kind of a green plastic?
Yeah, yeah, it's
Okay.
similar, it's similar to that. It's usually a poly or a plastic woven material. And it's kind of like a burlap sack type of a woven material, except it's made out of plastic, would be,
Okay.
the best way I can try to describe it.
I have a question. So does Foss Creek dead end at the art museum, or does it go underground?
Yeah, upstream, it's all box culverts. And then downstream, there's a park called Phelps Grove Park where it remains an open channel. And the floodplain impacts, there's no structural impacts to structures downstream. A lot of the floodplain ends up kind of ending up in the Phelps Grove Park area. And so, the project was just ended at Kings Avenue because that's what we needed. That's how far we needed to go to pull the structures out of the floodplain.
Thank you.
Okay.
Did any of the property, I'm sorry, one more question. Did any of the property flood during that 25-year flood event? Any of the neighboring properties?
No, not that I'm aware of, no.
Okay, I have Barbara and then me and then Jeff. Okay, Barbara, go.
Oh, yeah, thank you for your presentation. How many stream miles were involved in the project? Do you think?
Yeah, it was about, I want to say it was about 1,200 feet is what it was.
Oh, it was a relative,
1,200 linear feet, yeah.
it was small. And so is the feeling that it did help mediate some of the flooding downstream in the area around Phelps Grove Park?
It's more localized. I mean, it's definitely pulled the structures out of the floodplain, and the city is in the process of submitting a letter of map revision to revise the FEMA floodplain to formally change the mapping. That's still pending at this time, though.
Well, that's exciting.
Yeah, it is. I mean, it's one of those things, an individual property owner would not have the ability to do that. And so the fact that the city is able to do that for multiple properties and the art museum is really beneficial to the community. So
Yeah, and it also appears that it can show, relatively short distance of, and the stream can make a lot of a change in that small area has made a lot of difference to the surrounding areas. So that's really great. Thank you.
Okay, I wanted, you mentioned that Kings Avenue Bridge, that had to come down?
yeah,
And was there another bridge that had cars in it and that had to be down, or they were all the others just modified?
yeah, the others were modified. So there was a vehicular bridge that was modified to a pedestrian bridge. So
Okay.
there were a total of 3 bridges, and then 2 of them were modified and 1 of them was removed. And that was just to get better hydraulic performance, throughout the project area.
Now to a lot of people and a lot of politicians, the most sacred thing we have in American society is the automobile. Now, do you have any recollection of how much opposition there was to removing the bridge, or restricting the automobile traffic, and how did you deal with any problems that arose?
There was opposition from the neighborhood, and we used traffic data to justify that it was a low volume of traffic who would utilize that bridge, and show additionally that there were multiple other routes that the traffic could take. And we had a series of public meetings, and there still was opposition even after the meetings. But what helped justify it, I think, more so than the traffic volumes, was just showing the modeling and how removing that bridge affected the elevations of the floodplain. And that also helped justify the need for doing it. I think, one of the challenges about public projects is you'll never be able to make everyone happy. You just have to try to find the best solution for everyone. And it was just an act of trying to explain that and going through public meetings. And, you know, I think to this day, there still is opposition that there were some people who did not want that bridge removed, and they probably will always wish that the bridge was still there. But there are multiple ways to get, you know, around that neighborhood still, so.
Yeah, that's usually the case. Okay, Jeff, you had a question or comment.
I have a couple of questions. Kirkland, thank you for being here. It looks like you're still in the office working late. I'm a council member in U City, so I always appreciate staff members who take the time, especially in this case, to visit with us. So my first question is, in the city of Springfield, is the city of Springfield the stormwater authority?
Yeah. And I know there's some other ways municipalities organize and manage that infrastructure. Here in Springfield, it's a public works department.
Okay. Yeah, we're a little bit different. And the other question I had is that you gave, I took some pictures of some of the slides. Is that something you could send to me or to I'd like to get it to our public works director.
Yeah, sure. I provided a link to Don, and so yeah, Don, if you want to forward that link, or I can provide that.
Or Don, do I have that link?
It should, Kirkland, wasn't that in what I sent out tonight? I think the link you sent me, I put in the email. There is one link in the email.
Okay.
Okay. Yeah, if not, feel free to reach
Jeff,
out.
if you don't have it, look at your email for tonight. If you don't have it, send me an email and put you in touch with Kirkland.
I will. That's great. So Kirkland, do you have any suggestions, since you know, we have Metropolitan Sewer District, which is the regulatory authority over stormwater and sanitary in St. Louis County. And how complicated was it for Springfield to go through the process of these plans and taking out the concrete channels? Because what we've heard from MSD, Metropolitan Sewer District, is all of the concrete channels they are solely responsible for. So we don't have purview, and even the more natural channels, we have to get approval from MSD, the Army Corps of Engineers. What was that process like for approval?
Yeah, I mean, we did have to go through the Army Corps of Engineers. There's a 404 permit. And so they're usually a nationwide permit that covers these type of stormwater infrastructure projects, and that usually covers construction. As far as the municipality and just getting to the point of having a design and a construction, it was a factor of finding the money and budgeting for the project. And so due to the impacts to the art museum, it became a priority for the city to try to find some money to allow the art museum to remain, and then also address these residential structures. And that's where all those grants came in. Is typically stormwater it's not really a very well-funded utility. And so, you know, other utilities have ratepayers, and stormwater, it's just, I don't know, at least in Springfield, it's just a capital improvement where it's hard to find the money to budget for a project. So I just recommend, if you can find a grant that matches well with your goals, that's what we were able to do, and that's in a large part how we were able to be successful is filling the gap with grant money.
Thank you. And I just have one last follow-up question. I didn't see anywhere in the funding sources of federal money or state money. I mean, it's the state sitting on a lot of surplus. I think infrastructure projects are good. Was there any state money that came?
Yeah, there was quite a bit. A lot of it was administered through the DNR, the Department of Natural Resources. Through the DNR, there's the Department of Natural Resources. And so that's the state level grant money. That's the lion's share was a stormwater grant from the DNR. Also, Missouri Department of Conservation. That was our native planting grant.
Right.
And so a lot of it was state money. And it is challenging. The grants, there's an application process. And one of the things at the city of Springfield is we don't really have a grant application specialist. It just falls on the project manager to, you know, it's something I had to learn how to do. But it sounds like, you know, someone on the call mentioned they've touched base with a grant writer, which would be a huge advantage to applying for some of these grants.
Okay, Susan, are you your hand up again, or did you just not take it down?
I just didn't take it down. I also want to thank Kirkland for the information and the great presentation. And,
Yep.
you know, I have just a comment since Councilman Hale brought up MSD. And MSD appears to get federal monies, and I don't know if they get state monies, but those are monies that could come to the community instead. I don't know if that's possible, if they get the monies and decide which communities receive the improvements. That's an open-ended question. Thank you.
Barb has another question, comment, and I do also.
Another comment, because MSD has been providing grants and encouraging people to do rain gardens. So, you know, I'm wondering if they might be interested in this kind of a project. It's just a thought. I mean, they seem to be, a lot of their comments after the flood were they seem to be more interested in naturalizing the channel than I think they were before. That's just a feeling I got.
Thank you, Barb.
Okay, yeah, I have I guess a couple of questions are sort of a long question by themselves. One is that what surprised me is that you were able to get the idea of a naturalized solution across agencies and bodies that seem to me to be fascinated with cement. Like the par excellence is the Army Corps of Engineer, who think that every problem can be solved by cementing something. And I was really interested in how you know, if you had roadblocks in dealing with that, you know, and MSD in the St. Louis area seems to want to have grants for individuals to put a rain garden in their backyard. But as far as a naturalized general solution, I do not see MSD doing that. So do you, I guess what I'm asking is, did you run into the attitude that I've seen everywhere with people who deal with flood issues, that you solve every flood issue with a block of cement? And did you have to overcome that?
A little, but you know, mostly internally at the city, there's a little bit of hesitancy to make such a large investment in a non-concrete structure. You know, concrete is something people are comfortable with. It lasts 100 years. It's a good public investment, and that's just the mentality that some people have at the city. But as far as the grant agencies, I feel like they are fully in favor of this type of solution because it addresses multiple goals. You know, it addresses habitat for wildlife. It addresses water quality. And then for the community, I see it as an amenity. A lot of times, stormwater, it's concrete pipe that you just bury it and forget about it. But, you know, these type of projects, they're almost a park-like environment. And so it's able to be infrastructure that's visual, that people can enjoy, rather than just infrastructure that you bury.
Yeah, well, that I love the idea that concrete is something that you just put up and you forget about it, you know, for 100 years. We've had this wee problem in the area where a lot of us live, that water moves enormous pieces of concrete. And you don't just forget about concrete because it never cracks, it never splits, and there's never concrete washed into an area to block it. Now in terms, but in line with this long term, it would seem to me that native plants might be difficult because they tend to be overwhelmed by things like honeysuckle and lots of other stuff that want to take over any area. So do you have any sort of budget that, like in the River de Pere, there's just euonymus and honeysuckle and all sorts of junk, that has shallow roots, does not aid water absorption like natives do. Do you have any budget on for an annual basis for upkeep for native plants?
Yeah, there is. There's an annual budget, and there's a water quality maintenance crew who they specialize in these naturalized channels. And so that is something to consider. That native plants aren't maintenance free. There is still annual maintenance that would go into it.
Okay, and I see. Let's see. SN14JE looks a whole lot like Bob Chris, and after Bob, we have Connie Mueller, and then I'll ask if there's anybody who hasn't said anything before I call on Barbara and me again. Okay, Bob Chris, take it away.
Yes, Kirkland, two quick questions, but first, wonderful project and wonderful presentation once again. You mentioned a 25-year flood. Is that based on rainfall, or do you have monitoring in place?
Yeah, there's some rainfall gauges, and so we just looked at the gauge data over a period of time, and it was approximately a 25-year or 1 in 25 event.
Okay, the other thing is your project, though very laudable, would come out to $2,000 a linear foot. Is there anything that you've got the art museum and other things that certainly justify that kind of expenditure, but is there anything special like the bridge removals or something that elevated that cost over what would be a typical channel in most places?
Yeah, I mean, I would say the bridges elevated the cost quite a bit. And the fact that how they had to be installed due to being close to the art museum, like I mentioned, they had to pre-drill the holes for the piles rather than pile driving. And so it's kind of a non-typical construction technique that was required. So the bridges were a large expense that would not be typical to a project like this. The other thing is there was a sanitary sewer main running right through the channel, and they had to stabilize that before they could even start construction of the natural channel. So several other pieces of infrastructure, bridges and sanitary sewer that may not be typical on a typical channel project, elevated the cost.
Thanks very much. Great talk.
Okay, Connie Mueller, take it away.
Okay, thank you. Yes, this is a really exciting project. I'm so glad to hear about this. I'm on the Green Practices Commission in U-City, and we are investigating a tiny forest project, and I think that would be ideal for some of our floodplain areas, especially the areas that have been that FEMA has sponsored removal of houses, because no other construction can happen there. So if we have forests there, it might help mitigate some of the flood damage. But I have contacted MSD about funding something like this, and I didn't know if they would fund a municipality doing a project like this. It's not like a typical rain garden project, but they said it would qualify under their small grants program. So it sounds like they are being a little more flexible, not just sponsoring rain gardens in people's backyards. But I think if we just keep asking them, I mean, it can't hurt to ask about various things. I think they are changing their ways. So projects like this might fit in. And also in my investigating these tiny forests, I found that natural native plants are really, really an excellent thing to put on these banks, and that they do require some maintenance in the first couple of years, especially, and maybe even beyond that. But generally, once they get established, they're really pretty good at keeping out some of the invasives. Ruth Park Woods has degraded for so many years, and it's overrun with winter creeper and honeysuckle. But if it had been maintained and stocked with natives early on, I think it wouldn't be in this shape. So I'm very hopeful about a lot of our native solutions. So I'm really happy to hear about this. Thank you very much.
Connie, that was great. I really appreciate what you had to say about natives, and I hope that you're right about MSD and and other agencies really being interested, in going into a native direction. But and I hope it's not just something they're putting up for public relations. But sometimes I'm a wee bit skeptical. Okay, was there any? Let's see. We have Connie Fry from one Connie to another. Okay. Anyone else who wants to say something after Connie who hasn't said anything before? Not finding that. Okay. Connie Fry.
Hi, can you hear me?
Yeah.
Okay, great. I have a couple questions to the gentleman that presented this. Could you tell us a little bit more about the FEMA approval that you went through?
Well, it's a LOMR, a letter of map revision. And so what that would do is we submit our modeling and show, justify to FEMA that the floodplain extent should be modified. They review that, and then that will be formalized with a revision of the mapping. And so we're going through that process still with FEMA.
And can you tell me, kind of bouncing off of that, how long did this take from beginning to end, including all the grants and everything? I mean, if you want to put it in two different buckets, like, gathering all the money and the grants and things like that, and then when construction started and finished.
Okay, I would say the lead up is at least a year applying for grants and the design, going through the design process. And then construction was another year and a half, probably until it was fully completed.
And do you know about the Dubuque, Iowa project too?
The B branch,
Yes.
yeah, it's a similar type of project, yeah.
Did you glean anything from them before you started yours? I don't know. I mean, it is
No.
similar because we actually had the mayor in from Dubuque. This was a couple months ago, and he spoke, and it is, really similar to what you've done too. It just seems
Yeah.
like some of the things have been kind of narrowed down, and we've got some pat answers as far as fill and things like that that you talked about, that, that are tested and tried and true, that other people can't pick up on it and use it. Do you see that?
I think every problem kind of has its own unique engineering solution. That's just, the kind of the way I see it. But there is a push towards these naturalized channels. I feel like there's some momentum gathering in stormwater now that this is a good way to manage the floodplain, give it some area to let nature be nature. And so a lot of communities are doing similar things kind of independently. So, Springfield's doing this and it's a push from Springfield. And I think it sounds like Dubuque's doing this and it's a push from Dubuque. And so, individually, I feel like people are doing it because it's a good solution.
Well, it's good and it's smart. So maybe instead of taking similar techniques of, what you did during construction, maybe what we can glean from this is that these are successful.
Yeah, I think definitely, yeah.
I mean, really nobody can tell us, it's like, well, we don't know if this is going to work. Well, I think we can definitely have a voice to show people that it will work with examples of others, and then kind of go back to the board to figure out what would work differently in our situation. Beautiful job, by the way. It's really, really pretty.
Thank you.
Claudia, and then I think Barbara had another comment, unless somebody else does. And then I do. Go ahead, Claudia.
This is just a technical question. You said that FEMA required the Army Corps of Engineer modeling program, that elaborate diagram that you had. What was the name of that program?
Yeah, it's called HEC-RAS, HEC-RAS. And it's kind of the industry standard. I'm not sure that it may or may not be required, but pretty much everybody's going to be using HEC-RAS. It's just the tried and true method for modeling these riverine flooding hydraulics.
Okay.
And so if you do hire an engineer, that would be one thing to make sure, you know, in their qualifications that they have done HEC-RAS modeling and maybe have worked with FEMA, because it's kind of a unique skill set. Not every civil engineering firm would have the capability to do that.
Okay, I think that Barbara was next, and I saw that Edward Bayham put an interesting brief comment on the chat that I'm sure he would like an opportunity to expound on. Okay, Barbara.
Kirkland, did you have to have your engineering design done before you did your grant applications?
It wasn't completed. It was partially completed, and I would just say it helps to have it maybe to a 60% level, or at least a 30% level of design. And the reason I say that is it helps to have a cost estimate of some kind before you start going to these grant agencies, because typically the grant application will ask for what would be funded by the grant and what cost you anticipate that being. And so there's some level of effort even before you apply for these grants to get an idea of, you know, what you're asking for or what you think might be a good match for the grant investment.
So that's what I thought was probably the case. So the city of Springfield actually paid for that.
We did, yeah. So we paid for design with local funding. Yep.
And
some grants do have the ability to fund design. It'd just be a matter of finding the right grant that would fund design, and then get the design far enough along and maybe find another grant to fund construction. That's a technique you could try.
And I just also want to say that there does seem to be much more interest in naturalizing these channels and these floodplains than probably was the case in the past. And I saw one of your grantors was from the 319 program. And that's what the DNR, well, the EPA and then the DNR is really pushing. And those are all natural interventions for different kinds of flood problems and water pollution problems. So that I think there's a little bit of bright light there, frankly. So, and again, thank you. It was a great presentation.
Ed Bayham, did you have a thought that you might want to share with us? You still on? I see you're muted. Oh, there he is. Go ahead, Ed.
Yeah. Hi, Don. Yeah, I'm just typing a comment. You know, we members of the Sierra Club met with Brentwood a couple years ago to discuss their project and how it was working. And I was just typing in a comment here that just a couple weeks ago, with the recent flash rains we had, they did have flooding in Rock Hill, which is upstream of Brentwood. And Rock Hill did have flooding, particularly across Manchester Road, and affecting the lumber yard and some other businesses there. And it would be interesting to hear from someone from Brentwood as to how their project responded to the flooding where Rock Hill suffered.
Mm-hmm.
No, that would be
Yeah,
interesting.
that's interesting. Yes.
Okay, one thing that I wanted to sort of a comment and question for responses from Kirkland and Susan Armstrong, and that is, for decades, my specialty is psychology, so I really don't know much about engineering and such. But for decades, I've heard of biological architecture, where people, look at how you design houses in connection with plants. And the natural world, have the house be an extension of the natural world. I've never heard of such a thing as a specialty in biological engineering. But it seems like that's what you needed to have for these grants. Is there such a thing as a specialty for biological engineers? And where do you find them if we wanted one?
I think this is Susan Armstrong, Stormwater Commissioner, PE. I think Mr. Kirkland said it's a landscape engineer.
Oh,
Yeah.
landscape engineer. Very good.
Landscape engineer, right.
Okay.
Yeah, I mean, when we hired our engineering firm to design the project, we wanted them to have a landscape architect on the team, just primarily to give advisement on the native plantings and how to best utilize those, so.
Yeah, well, that sounds extremely important, you know, that we have, that if we ever were able to do something like that in St. Louis, in the greater St. Louis area, that we would be able to find people who were experts in that area. And I know that Ed would give us lots of suggestions from the Sierra Club's vast repertoire of knowledge of people who specialize in this. Okay, is there any other questions or Connie Fry? Go ahead.
Don, maybe you can address this, and maybe I dreamt it or whatever. It was a good dream. Anyhow, did we not have a rainfall recently in the Heights, especially those where you live, and that it was similar to 2022, and we did not get flooding, and that was after the cleanup of the tunnels?
Well, yeah, but the rainfall was a little bit less, and I think that Mark Holly's model showed that the effect of the tunnel blocking things would happen at a certain amount, like 10% obstruction, and maybe Susan, Susan, if Bob Chris is still here. And it would seem to me that there would be a critical point in the amount of water going through before the water starts to back up, and then when it backs up, it would be really rapid. So Bob and I think you know a little bit more about hydrology than I do. So what would be your take on why there was no flooding in the Heights of the flood of the heavy rainfall a few weeks or a couple of months ago, while it was absolutely enormous, you know, in July of 2022? I think we might have missed Bob. Okay. Susan, do you have any thoughts on that?
Nope, I would, Dr. Chris would have thoughts on that.
Yes, we only had an inch an hour in the last flood. We need an inch and a half an hour before we start to have problems. The flood at the USGS gauge was 4 feet lower than the 2022 event. So it wasn't, this was a near problem, but we did not, our flood warning system did not even issue a warning this time, and that was the correct response.
Okay, so you're saying was it an inch an hour versus an inch and a half an hour?
That's all the difference in the world.
Right. And you don't get 2/3 of a flood when it's an inch of hour.
We had over 2 inches an hour for 3 consecutive hours.
Okay, and so that's and the tunnel
It's
just
a big difference. Okay,
the tunnel just can't absorb anything like that, like 2 inches an hour.
right.
Okay, so
That's no problem for us.
yeah, so basically, there's a critical amount of water that needs to be going through, and once you pass that critical amount, water starts to go up very rapidly.
Right.
Okay, well, you know, we have covered a lot of things tonight. Kirkland, do you have any closing words of wisdom you could share with us?
No, I don't. You know, thanks for having me. And if you have any questions, you can feel free to reach out, you know.
Okay, thank you very much.
Yeah.
Anyone else have a final, a parting comments or thoughts? Okay, well, hopefully we will have some legislation going from the Stormwater Commission in University City to the City Council on absorption of water in University City and what we can do about that. But we will just see if we do that, we might want to have our next flood discussion, you know, about what legislation would be in University City and have people share their thoughts about it. But I want to thank everybody for coming tonight. We were just a little bit over an hour, which I think is
Yeah.
just about everybody's preferred time period for a good discussion.
Thank you so much, Kirkland.
Thanks, Kirkland. Thank you.
I feel a little inspired. I feel very inspired. It's great.
Yeah, and if we ever start to get off the ground and get momentum going, you may be sorry for the statement that we could just call you up anytime we felt like it.
Yeah, feel free to give me a call, honestly. Yeah, if you have some questions, I'll be happy to talk with you.
Okay, fantastic. Okay.
Thank
Okay.
you.
Thanks everybody for joining us.
Bye, everybody.
Yeah.
Let's say